Non-Participation Air Forces, EPAF, as 116 for Belgium, 58 for Denmark, 102 for the Netherlands, and 72 for Norway. 2 European production lines, one in the Netherlands at Falcon's Schiffolust facility and Theater at Subke's Gosselais plant in Belgium, would produce 184 and 164 units respectively. Norway's Kongsberg Våpenfabrik and Denmark's Terma /S also manufactured parts and sub-assemblies for EPF aircraft. European co-production was officially launched on the 1st of July 1977 at the Falcon factory. Beginning in November 1977, Falcon-produced components were sent to Fort Worth for fuselage assembly, then shipped back to Europe for final assembly of EPAF aircraft at the Belgian plant on the 15th of February 1978. Deliveries to the Belgian Air Force began in January 1979. The first Royal Netherlands Air Force aircraft was delivered in June 1979. In 1980, the first aircraft were delivered to the Royal Norwegian Air Force by SABCA and to the Royal Danish Air Force by Falcon. 42-43. During the late 1980s and 1990s, Turkish Aerospace Industries, TAI, produced 232 Block 30/40/50 F-16 Sunna production line in Ankara under license for the Turkish Air Force. TAI also produced 46 Block 40s for Egypt in the mid-1990s and 30 Block 50s from 2010 onwards. Korean Aerospace Industries opened a production line for the KF-16 program, producing 140 Block 52s from the mid-1990s to mid-2000s decade. If India had selected the F-16 in for its medium multi-role combat aircraft procurement, a sixth F-16 production line would have been built in India. 44. In May 2013, Lockheed Martin stated there were currently enough orders to keep producing the F-16 until 2017. 45. Improvements and upgrades. One change made during production was augmented pitch control to avoid deep stall conditions at high angles of attack. The stall issue had been raised during development but had originally been discounted. Model tests of the YF-16 conducted by the Langley Research Center revealed a potential problem, but the laboratory was able to duplicate it. YF-16 flight tests were not sufficient to expose the issue. Later flight testing on the FSD aircraft demonstrated a real concern. In response, the area of each horizontal stabilizer was increased by 25% on the Block 15 aircraft in 1981 and later retrofitted to earlier aircraft. In addition, a manual override switch to disable the horizontal stabilizer flight limiter was prominently placed on the control console, allowing the pilot to regain control of the horizontal stabilizers, which the flight limiters otherwise lock in place, and recover. Besides reducing the risk of deep stalls, the larger horizontal tail also improved stability and permitted faster takeoff rotation. 46-47. In the 1980s, the Multinational Staged Improvement Program, MSIP, was conducted to evolve the F-16's capabilities, mitigate risks during technology development, and ensure the aircraft's worth. The program upgraded the F-16 in 3 stages. The MSIP process permitted the quick introduction of new capabilities at lower costs and with reduced risks compared to traditional independent upgrade programs. 48. In 2012, the USAF had allocated $2.8 billion to upgrade 350 F-16s while waiting for the F-35 to enter service. 49. One key upgrade has been an autopcus, ground collision avoidance system, to reduce instances of controlled flight into terrain. 50. Onboard power and cooling capacities limit the scope of upgrades, which often involve the Addition of more power-hungry avionics. 51. Lockheed won many contracts to upgrade foreign operators' F-16s. BAE Systems also offers various F-16 upgrades, receiving orders from South Korea, Oman, Turkey, and the U.S. Air National Guard. Winking sad smiley. 52, 53, 54. BAE lost the South Korean contract because of a price breach in November 2014. 55. In 2012, the USA fastened the total upgrade contract to Lockheed Martin. 56. Upgrades include Raytheon's Center Display Unit, which replaces several analog flight instruments with a single digital display. 57. In 2013, sequestration budget cuts cast doubt on the USAF's ability to complete the Combat Avionics Programmed Extension Suite, CAPES, a part of secondary programs such as Taiwan's F-16 upgrade. 58. Air Combat Command's General Mike Hostage stated that if he only had money for a Service Life Extension Program, SLIP, or CAPES, he would fund SLIP to keep the aircraft flying. 59. Lockheed Martin responded to talk of CAPES cancellation with a fixed-price upgrade package for foreign users. 60. CAPES was not included in the Pentagon's 2015 budget request. 61. The USAF said that the upgrade package will still be offered to Taiwan's Republic of China Air Force, and Lockheed said that some common elements with the F-35 will keep the radar's unit costs down. 62. In 2014, the USAF issued a RFI to slip 300 F-16C/DS. 63. Production relocation. To make more room for assembly of its newer F-35 Lightning II fighter aircraft, Lockheed Martin moved its F-16 production from Fort Worth, Texas to its plant in Greenville, South Carolina. 1. Lockheed delivered the last F-16 from Fort Worth to the Iraqi Air Force on the 14th of November, 2017, ending 40 years of F-16 production there. The company resumed production in 2019, though engineering and modernization work will remain in Fort Worth. 64. A gap in orders made it possible to stop production during the move, after completing orders for the last Iraqi purchase. 65. The company was negotiating an F-16 sale to Bahrain that would be produced in Greenville. This contract was signed in June 2018. 3. And the first planes rolled off the Greenville line in 2023. 66. Design overview. The F-16 is a single-engine, highly maneuverable, supersonic, multi-role tactical fighter aircraft. It is much smaller and lighter than its predecessors but uses advanced aerodynamics and avionics, including the firstness of a relaxed static stability fly-by-wire, RSS/FBW, flight control system, to achieve enhanced seat maneuver performance. Highly agile, the F-16 was the first fighter aircraft purpose-built to pull 9G. Early late comparison between F-16's inset cannon. Early aircraft had 4 leading vents, a grille, and 4 trailing vents, while later aircraft had only 2 trailing vents. Maneuvers and can reach a maximum speed of over Mach 2. Innovations include a frameless bubble canopy for better visibility, a side-mounted control stick, and a reclined seat to reduce G-force effects on the pilot. It is armed with an internal M61 Vulcan cannon in the left-wing root and has multiple locations for mounting various missiles, bombs and pods. It has a thrust-to-weight ratio greater than 1, providing power to climb and vertical acceleration. 67. The F-16 was designed to be relatively inexpensive to build and simpler to maintain than earlier generation fighters. The airframe is built with about 80% aviation-grade aluminum alloys, 8% steel, 3% composites and 1.5% titanium. The leading edge flaps, stabilators, and ventral fins make use of bonded aluminum honeycomb structures and graphite epoxy lamination coatings. The number of lubrication points, fuel liner connections, and replaceable modules is significantly lower than preceding fighters. 80% of the excess panels can be accessed without stands. 44. The air intake was placed so it was rearward of the nose but forward enough to minimize airflow losses and reduce aerodynamic drag. 68. Although the LWF program called for a structural life of 4,000 flight hours, capable of achieving 7.33 with 80% internal fuel, GD's engineers decided to design the F-16's airframe life for 8,000 hours and 49G maneuvers on full internal fuel. This proved advantageous when the aircraft's mission changed from solely air-to-air combat to multi-role operations. Changes in operational use and additional systems have increased weight, necessitating multiple structural strengthening programs. 69. General configuration. The F-16 has a cropped delta wing incorporating wing fuselage blending and four-body vortex control strakes, a fixed geometry, underslung air intake, with splitter plate, 70, to the single turbofan jet engine, a conventional triplane empennage arrangement with all moving horizontal stabilator tailplanes, a pair of ventral fins beneath the fuselage aft of the wing's trailing edge, and a tricycle landing gear configuration with the aft retracting, steerable nose gear deploying a short distance behind the inlet lip. There is a boom-style aerial refueling receptacle located behind the single-piece bubble canopy of the cockpit. Split flap. Jet heavily armed with weapons under wings taking off. F-16 CJ of the 20th Fighter Wing from Shaw AFB, South Carolina, armed with a mix of air-to-air missiles, anti-radiation missiles, external fuel tanks and support equipment. Speed brakes are located at the aft end of the wing body fairing, and a tailhook is mounted underneath the fuselage. A fairing beneath the udder often houses ECM equipment or a drag chute. Later F-16 models feature a long dorsal fairing along the fuselage spine housing additional equipment or fuel. 44. 71. Aerodynamic studies in the 1960s demonstrated that the vortex lift phenomenon could be harnessed by highly swept wing configurations to reach higher angles of attack, using leading edge vortex flow off a slender lifting surface. As the F-16 was being optimized for high combat agility, GD's designers chose a slender cropped delta wing with a leading edge sweep of 40 degrees and a straight trailing edge. To improve maneuverability, a variable camber wing with a NACA 64204 airfoil was selected. The camber is adjusted by leading edge and trailing edge flap airons linked to a digital flight control system regulating the flight envelope. 44. 69. The F-16 has a moderate wing loading, reduced by fuselage lift. 72. The vortex lift effect is increased by leading edge extensions, known as strakes. Strakes act as additional short-span triangular wings running from the wing root, the junction with the fuselage, to a point further forward on the fuselage. Blended into the fuselage and along the wing root, the strake generates a high-speed vortex that remains attached to the top of the wing as the angle of attack increases, generating additional lift and allowing greater angles of attack without stalling. Strakes allow a smaller, lower aspect ratio wing, which increases roll rates and directional stability while decreasing weight. Deeper wing roots also increase structural strength and internal fuel volume. 69. 73. Armament. Aircraft carrying missiles on tips of wings during flight over ocean. Under each wing is a cylindrical external fuel tank with pointed nose. a Portuguese Air Force F-16A outfitted with AIM-9 Sidewinder missiles, and /ALQ-131 ECM pod and external fuel tanks. Early F-16s could be armed with up to 6 AIM-9 Sidewinder heat-seeking short-range air-to-air missiles, AAM, by employing ray launchers on each wingtip, as well as radar-guided AIM-7 Sparrow medium-range AAMs in a weapons mix. 74. More recent versions support the AIM-120 AMRAAM, and U.S. aircraft often mount THAAD missile on their wingtips to reduce wing flutter. 75. The aircraft can carry various other AAMs, a wide variety of air-to-ground missiles, rockets or bombs, electronic countermeasures, ECM, navigation targeting or weapons pods, and fuel tanks on 9 hardpoints, 6 under the wings, 2 on wingtips, and 1 under the fuselage. 2 the locations under the fuselage are available for sensor or radar parts. 74. The F-16 carries a 20mm, 0.787 in, M61A1 Vulcan cannon, which is mounted inside the fuselage to the left of the cockpit. 74. Relaxed stability and fly-by-wire. The F-16 is the first production fighter aircraft intentionally designed to be slightly aerodynamically unstable, also known as relaxed static stability, RSS, to both reduce drag and improve maneuverability. 76. Most aircraft are designed to have positive static stability, which induces the aircraft to return to straight and oval flight attitude if the pilot releases the controls. This reduces maneuverability as the inherent stability has to be overcome and increases a form of drag known as trim drag. Aircraft with relaxed stability are F-16C of the South Carolina Air National Guard in flight over North Carolina, equipped with air-to-air missiles, bomb rack, targeting pods and electronic countermeasure pods designed to be able to augment their stability characteristics while maneuvering to increase lift and reduce drag, thus greatly increasing the maneuverability. At Mach 1, the F-16 gains positive stability because of aerodynamic changes. 77, 78, 79. To counter the tendency to depart from controlled flight and avoid the need for constant trim inputs by the pilot, the F-16 has a quadruplex, 4-channel, fly-by-wire, FBW, flight control system, FLCS. The flight control computer, FLCC, accepts pilot input from the stick and rudder controls and manipulates the control surfaces in such a way as to produce the desired result without inducing control loss. The FLCC conducts thousands of measurements per second on the aircraft's flight attitude to automatically counter deviations from the pilot set flight path. The FLCC further incorporates limiters governing movement in the 3 main axes based on attitude, airspeed, and angle of attack, AOA, /G. These prevent control surfaces from inducing instability such as slips or skids, or a high AOA inducing a stall. The limiters also prevent maneuvers that would exert more than a 9G load. 80, 81. Flight testing revealed that assaulting multiple limiters at high AOA and low speed can result in an AOA far exceeding the 25 degrees limit, colloquially referred to as departing. This causes a deep stall, a near free fall at 50 to 60 degrees AOA, either upright or inverted. While at a very high AOA, the aircraft's attitude is stable but control surfaces are ineffective. The pitch limiter locks the stabilators at an extreme pitch up or pitch down, attempting to recover. This can be overridden so the pilot can rock the nose via pitch control or cover. 82. Unlike the YF-17, which had hydromechanical controls serving as a backup to the FBW, General Dynamics took the innovative step of eliminating mechanical linkages from the control stick and rudder pedals to the flight control surfaces. 83. The F-16 is entirely reliant on its electrical systems to relay flight commands, instead of traditional mechanically linked controls, leading to the early moniker of the electric jet and aphorisms among pilots such as "You don't fly an F-16, it flies you." 84. The quadruplex design permits graceful degradation in flight control response in that the loss of one channel renders the FLCS a triplex system. 85. 86. The FLCC began as an analog